Within the major body cavities, we're going to have a special type of lining known as a serous membrane. The serous membrane is going to consist of two different layers, a layer against the wall of the cavity and a layer on the surface of the organ itself. Now, the idea behind having two layers is we want to reduce friction for organs that move a lot. For example, if I were to remove the lungs here in the thoracic cavity and give us a better view of the heart needs to beat all day, every day, and we do not want to have a lot of excessive friction between the heart and the surrounding structures as it beats throughout your life. That would increase wear and tear and likely lead to a lot of damage to the tissue of the heart itself. Now, the idea behind a serous membrane can best be explained perhaps by looking at a simple drawing of a balloon. Here, I've drawn the balloon, which has one layer of thickness surrounding an inner cavity. In this case, the cavity might be filled with air or even potentially water, but it is airtight, meaning that there's not going to be a way for that air or fluid to leave that inner cavity. Let's say hypothetically you were to shove your fist down into that balloon. What you've now done is created two layers out of what was once a single layer. You have a layer tight up against the surface of the fist and an outer layer that is separated from that inner layer by a cavity that could be filled with either air or some form of liquid material. We also have a gap that would allow for passage of structures in and out of that inner aspect. In this case, our wrist, containing the arteries and tendons and structures that are important to make our hand move, can freely come in and out of this gap without penetrating through the actual lining of the balloon, which would cause air or fluid to leak. This is the same concept with our key organs. Now, around the heart and the lungs, we're going to want to have structures pass in and out of that organ, but we want to have an area that would allow for movement in an essentially frictionless environment. You could slightly squeeze and expand your hand, and it would not really affect the outer lining of this structure. Reality is that we're going to have two different layers, so we need to be able to name them depending on their location. The outer layer is known as the parietal layer, and the inner layer that would have surrounded the fist, or in this case one of these organs, is known as the visceral layer, with viscera meaning organ. Each serous membrane is going to have two descriptive terms. The first describes is it on the wall or on the organ itself. The second term is going to tell us of which cavity. So we're going to have a pleural cavity surrounding the lungs, a pericardial cavity surrounding the heart, and a peritoneal cavity surrounding the abdominal organs. By combining these terms, parietal or visceral, with either pleural, pericardial, or peritoneal, we get a distinct description of which layer we're looking at. For example, the parietal pleura is going to be the layer lining the walls of the pleural cavity, whereas the visceral pleura is the layer lining the actual surface of the lung itself. The visceral pericardium is the layer lining the actual surface of the heart, and this would be continuous with the inner aspect of a structure known as the pericardial sac, which is lined by the parietal pericardium layer. Lastly, visceral peritoneum would then line an organ within the abdominal cavity. And we can see by zooming in that there's going to be a thin reflective layer on the surface of the stomach, as well as on the liver, the gallbladder, or the large and small intestine, which are also highly mobile organs within the abdominal cavity.